Hello, good people of YouTube. Today we have a new topic with the brand new release of the IBM Cloud Pak for AIOps version 4.10.0. And out of that release, we have carved out two topics. One is single point of failure detection using topology, which is in AIOps, as well as risk detection using GIS data and a few new observers that we have in the product now. And for that topic, we have Matt Duggan, one of our senior technical staff members of IBM Research and Development, and he's going to take you through the whole topic. So the agenda is pretty quick, just a few points. So we will start with single point of failure detection in partial topology graphs. So this is a thing within the Cloud Pak for AIOps. This is using topology data and then finding out if these graphs do expose some kind of single point of failure attributes or capabilities. That is exactly what we're going to expose. That is a feature we had in the product already for some time. Well, in the back end of the product. And now we have tested it thoroughly and we're going to expose it and make it available for everybody to use because it's pretty cool. So looking forward to the demo of Matt. And the second topic we're going to talk about is external risk detection. For that, we do have a number of new things within the Cloud Pak, and I'm really looking forward to this topic as well. We're talking to NASA data, we're talking to a lot of other external stuff that we're going to integrate using our new observers. And we're going to merge this kind of external insights with GIS data. So you need to have this lat-lang enrichment enabled. And as you have that, then we are capable of deduct a number of really cool insights. And after the demo of Matthew, I'm going to conclude with a few links into our documentation, where to get started. And with that, I'm looking forward to your demo. Matt, over to you. Take it away, please.
What we've got in this system is a load of demo data. So there's a fake LTE network, a fake telco network, and then we've got some geospatial stuff we'll get onto. But the first thing I wanted to talk about was what we're calling single point of failure capability. So if you imagine a network of connected routers, switches, and servers, ideally that would be fully resilient in that there's no single point of failure. But typically what we find is that there's kind of risk points in most topologies where if you were to remove, for example, a gateway router, it would mean that devices in the office might not be able to access the internet. What we've done is we've essentially enabled a capability we've had for a while in the back end, but we've now added a way of accessing that in the UI. And what we can do is we can look at a topology. In this case, we're looking at a group, and it's a fake telco network. It's actually based on a real customer's network, so structurally it is accurate. And what we're going to do is explore how this new capability can help you gain a little bit of insight into whether there's any risk points in this network or not. And the aim is to help the end user sort of assess whether or not if a device has got a problem, is it more of a problem than it might be normally, for example, or if you were to do some maintenance window planning, this capability might help you sort of put extra process in place, because taking out a device that would split your topology essentially is probably not a good thing. In this example, what we can see is we've got this topology. It's not immediately obvious whether or not this is fully resilient. So if we tick this little button on here, show single points of failure in the current topology, and current is a key thing here that we'll get into a bit more, what we'll do is we'll mark any nodes or edges that are single points of failure. And so in this case, you'll note that nothing has changed. And that's because this particular topology is resilient. It's very highly redundant, and there's no one single point in this in terms of node or relationship that if it were to be removed would cause a problem. So we've done kind of a counter example in this case. But now what we'll do is we'll go and look at a version of that topology where we do have a single point of failure. And so again, it's not immediately obvious where that might be, but if we turn a little switch on, then what we'll do is we'll highlight that point where if we were to remove this device here, it would essentially make ASH R04 unreachable. And so what we've done is we've marked the node and we've marked the relationship that are considered to be single points of failure. So in product terms, the backend considers this thing to be a cut vertex and this thing to be a bridge edge, in that if they were removed, you wouldn't be able to get to this. You can do some nice styling changes here. So if I go and look at topology config and advanced settings, rendering, we can choose how we render this. So there's some new controls here. So I can choose the accent color and I've gone for red. I think it defaults to orange. You can choose the style of the line. So I might change that to long dashes. And you can also choose the icon as well if you want to. So maybe we'll choose an alarm icon and we'll go and save that. And if we go back, what we should see is we'll get those reflected in the screen. Yeah, so now we've got an alarm icon, a little bit different styling on that relationship. That's a little example. If we look at a big example, so in this case, we're going to run that tool against the topology for the whole of the London Underground. And so it's quite big. There's about 500 stations or so and lots of relationships. And so again, it's not immediately obvious where we've got potential kind of single points of failure here. But if I run the tool, what it'll do is it'll go back, get the data, and it will highlight again where we've got these articulation points in the topology that if we were to remove these, then we've got a problem essentially. So as you would expect, there's some lines that are kind of spur lines in a physical transport network. So we can see here a nice example where if we were to lose the North Acton station, then we lose an awful lot downstream of that. So you wouldn't be able to get to any of these stations here. So for example, what's this one? West Ruislip and so on. They all depend on North Acton being healthy, essentially. With that, I will go on to the next demo. In this topology here, we've got web and a whole load of stuff related to it. It's Kubernetes stuff. What you can do is you can run this tool anywhere. So I can turn it on here, but the sort of cautionary tale is that this is not operating on the whole graph of potentially millions of resources. It's operating on whatever the response from the API behind this screen is. So in this case, this is accurate in that for this topology, these things are single points of failure. It might be, but if I went another step out or another 2 steps out, that they are no longer single points of failure because there's kind of additional things in the graph that we haven't yet got to. Although you can use it here, I think the guidance would be to try and use it for things like groups where the topology is kind of whole, if you like in the other examples that we looked at. It's out of the box. It's just you turn it on or off, and yeah, you get this extra insight. It doesn't care about the relationship types or resource types. It'll work with anything essentially. So behind the covers, it's just a depth first search algorithm that's being ran, and we're marking the nodes appropriately. If there were to be an affinity with a particular kind of out of the box integration, it's well suited to those that can provide you with these kind of whole fragments of topology, if you like, where if we look at this one, you consider this to be essentially a set of topology you want to apply that analysis to. Things like the Kubernetes observer would probably be a decent example if you were creating groups for services and deployments, that kind of thing. But I would say it's probably more in tune with some of the network discovery stuff. So ITNM sort of data, for example, if you were to bring that in and you had a group that represented your BGP network, that's a good example of where you could point that analysis at and say, actually, I've got a router here where I might lose BGP connectivity if that was taken out. But it will work with anything. It doesn't care about the relationship types or the resource types. The next one then is the work we've done around what's being called external risks. We've had a geospatial capability in the product for a while now, and what we've done is we've expanded on that and worked with customers to introduce a capability that I think we're pretty excited about. And the idea is that if you've got environment, then it's more likely than not that you're going to have physical sites deployed. So telco, classic example, banks, etc., very widely dispersed physical environment with lots of sites. And what we're hearing increasingly is that the weather patterns that we're probably all experiencing to varying degrees are a problem. Talking to a customer in North America, they have big problems with wildfires burning their cell towers, and Europe, we have similar problems as waves, wildfires in Greece at the moment, and the UK, it's more of a flooding problem, I would say. But basically what we've done is we've done some new visualization and analysis capabilities and new integration capabilities to try and help solve or at least help customers manage these kind of problems. Because the customer we talked to in North America, they have some proprietary and kind of other systems that they use to help assess whether a wildfire is a risk to their network. But it's a very manual process. So they literally go and click on a fire, measure how far away it is with a pointer to their nearest router or site or whatever it might be, and draw an assessment from that. So what we're trying to do is help automate that a bit. If I go and look at the new observer, what you will see is a thing called the external risk observer, and that is here. And so if I go and just show you a little bit what this looks like, there's a number of different job types with it. They're all documented, and so as to which one makes sense to your use case, you'll need to go and look. But essentially, they fall into a couple of categories. So NASA firms is getting what you could consider to be more kind of raw data about where there's hotspots. According to some of NASA's satellites, it will reveal things like, here's basically an area that's hot. So it could be a fire, but I've seen things like volcanoes returned by it and steelworks, that kind of thing. So it will return more raw data. Whereas these these job types, they make use of IBM's Environmental Intelligence Suite, and it's more curated data here. So there's a couple of variants on the ability to get wildfire, and we were very keen that these had global coverage. That's a bit of a challenge with this because you can get better quality data for the US and Canada, but we clearly have customers outside of those countries. So these all have global coverage. And so what you would do is you would choose one of these, OSPO, Fire and Wildfire 2. They're similar. And then alert headlines and watches and warnings are interesting because they can give you some additional data that you wouldn't get from the others. So things like flood warnings, air quality warnings, heat warnings, for example, that kind of thing can be retrieved by these job types. And many of them follow a similar pattern. So if I just go and look at the alert headlines one for a moment, it's the usual thing with the parameters you would specify. So you need an API key. You can choose the country that you're interested in. And then you can also do some interesting stuff around sort of limiting the scope of where we get data for. So if I just show you how you could go about doing that, what you'll see in the job definition is a placeholder that says limits the external risk observed to be within the given bounding windows. That can actually be a shape. And so the way you get that shape at the moment is you can use an external tool like GeoJSON.io or something like that. Or what I tend to do is come here at the moment, basically start to create a filter. So geospatial filter within area, and then you can select the area using the polygon tool. If I were to do this, what I then get is a polygon in Wicket format, and I can then paste that in there, and that will serve as the region that I go and look at, even though I might have specified the broader US as the target. I can be very specific about what we focus on. If I go back to the list, what you'll see is there's a number of jobs here that have ran. There's Canada, we've got some ones for Greece, the UK and the US. When those jobs run, they get data about what we would consider the external risks related to them. And if we go back in the UI, what we'll be able to see is new types of things. So if I do a search for fire, so here are the fires that have been detected And so we can see that these are from NASA, and I can go and look at the details of that, and we get a little bit of information about this. So things like how bright it is, essentially how hot it is, and we can also see naturally where that is on a map. Some of the other job types give you a little bit more information. So if I do a search for wildfire, so these will be from the weather company or the EIS APIs, and so we can also figure out kind of where they are in human terms. So instead of just saying there's a lat long, some of them have the option to geocode the lat long to something readable. So things like Albany, Georgia, for example. And if we just go and look at the details for one of these, we can get a little bit more information often about what the nature of this thing is. And let's just try the alert headline one. And again, we'll get some different ones here. So actually some interesting ones. There's flood advisories, extreme heat warnings, and so on. So if we go and look at the flood advisory, you get a lot more information from the alert headlines based jobs than the others, but it gives you a lot of information about kind of the provenance, where the data is coming from, how likely is it to happen, etc. Again, where that thing is. So now we've got all of this data, what I'm going to do is I'm going to create a new filter. And what this will let me do is it will let me use the new UI capability to pose the question as, has my equipment got any risks, essentially. So what I'll do is I'll do fire, wildfire, and I think it was alert headline. And so if I apply those, we should get quite a few things returned. And what I'll do is I will save that as, I'll call it my risks. And so then what we can do is we can go and look on a map and see where in the world I've got these my risks. Unsurprisingly, because we've got jobs running again pointing at Greece, there's some big fire problems in Greece at the moment, and we've got a lot going on in the US and Canada. The same experience applies. If I zoom into these, I can go and start to see what's happening, and we'll actually have polygons for some of these because we can derive polygons from the shapes, otherwise they're points. But we can see heat advisories. What's this one? A fire detected near Yellowstone, etc., etc. So now what I want to do is I want to ask the question, have I got anything near any of my equipment? So we've already managed to get the fact that there is fires and floods and all sorts of stuff going on. But what I'll do now is I'll say, use this new UI proximity mode and run the my risks filter against US routers. And let's say I want to find anything within 10 kilometers of my equipment. And so what it's done now is it's found that there's actually a couple of real occurrences of these weather phenomenon near what happens to be some fake data for this network. But it means we can quite easily go and understand that there's something here that might be a risk. And so the way we depict this is you have a little radar display. And so the radar lets you kind of understand the range, distance and bearing between, in this case, the router at the top and a fire at the bottom, a wildfire at the bottom. And so what we've got here is we can see clearly that the wildfire is near that router. And if you click on the line, you'll see the distance. So we've got a fire about 1.5 kilometers away from that router in that case. And the one on the east coast of the US, if we go and have a look at that, it's probably a similar thing. So we've got one of our fake routers and it's actually a flood watch. So yeah, bit of a different one. But what this is saying is, you know, we've detected from the EIS APIs that there's a flood watch warning in place for that region, and we've got some equipment near it. I know one of our customers in North Carolina was very badly affected by some flooding last year. So it's this kind of thing that helps with that. And then I know we're not got much time left, but sort of last but not least, perhaps, is I just wanted to show how this can work with complex geometry. So we talked about sort of points essentially. So you can consider the router as a site and the fire as a site in this case, but we can get polygons and we can model things like line strings as well. So in this case, what we're going to do is say, I've got all of the UK motorways modeled, and I want to go and understand, have I got any fake LTE sites within a kilometre of any of the motorways? And so if I run the tool there, what this has done is essentially it's gone along each motorway and said, is there an LTE site within a kilometre of that? What you'll see here is, again, we've got the little radar display. So here's an LTE site, and it's near that particular fragment of motorway. It's quite a long fragment of motorway, that one. But the same principles apply. You get the little radar display, and we'll also draw the line from, in this case, the fake LTE sites to the nearest point of the motorway. So it's not sort of going to the centroid of the motorway or the point on the motorway that's in the middle. It's finding where it is along the nearest sort of stretch of that, if you like. And the idea here is, based on some of the discussions we've had with our customers in North America, is they've got fibers and microwave transmissions and they can model those, but they want to know if there's risks that could be related to those and what's the nearest point. So if I've got a fire near my fiber, where do I need to go to potentially head that off or plan accordingly? That was about it. Are there any questions? We do raise alerts for these things. So if we go and look at the alert view, you'll see that we raise fire detected type alerts and so on. So the external risk observer will generate alerts for you that you can factor into your your alert processing. The bit that's missing at the moment is we don't automatically raise an alert if there's something at risk. So that whole thing I showed you in the UI where we say, tell me if I've got something within 10 kilometers of my router, we don't currently automatically raise an alert saying, hey, be aware that there's a fire near your kit. That's something that we're discussing at the moment, but we do raise the alerts for whatever we detect, as you can see here. And you could use the file observer if we don't have an out-of-the-box integration, or if the new external risk observer doesn't get the power outages, for example, then you can do this with the file observer. You can just model whatever geometry you want as part of the regular things you would put in a file. All right, thanks very much.
Thank you, Matt. That was fantastic. Haven't I talked too much? Yeah, that was really cool. I loved it. And how to get these kind of topics within our documentation reflected. So for beginners, there's the release notes. We are now in the IBM Cloud Pak for AIOps version 4.10.0. And there is in the release notes a section which is called What's New. In there, we're trying to highlight all the nitty-gritty details of what is new in this release, as well as we do have further data points in the documentation. And that is, for example, configuring the advanced settings. And that is something where you can enable these kind of rules that you will need to make these kind of changes. And there's a last piece I'd like to show you. The external risk observers are also new, capable in here. And just to get to this link, search for risk observer, and then you will find this chapter in the current documentation, and there you will find Environmental Intelligence Suite, NASA, and all these kind of things that we're going to use within our environment. And with that, I'd like to thank you for spending such time with us, and I'd love to see you again in another of the instances of AIOps Explained. And a very special thank you to Matt for the demo and explanations today. And see you another time. Bye.